What I wanted to first mention was you may have noticed when you solve some of those replets, you know, it's not a perfect system where, um, in theory, I'll put the replets that you can solve based off of what we have covered. However, because we're trying to, with the very nature of a boot camp, is cover a lot of material in a short amount of time. And so it's a balancing act for me because, really I should be going faster. At the same time, I want you all to be able to follow the material. But again, there's only so much following of the material you can do if you are kicking the ball. But as I look at the names in this list, I can guess, not guess, I actually was just looking at who did the replets from last time, and majority of the people in this room were those who were in fact doing the replets. And I also may guess that the number of participants will slowly, or has slowly dwindled down. It may not dwindle much beyond this because I think most of you are doing the replets, in which case there's value for you to continue coming, right? But I think it's unfortunate, but the message that others will have received, which is an accurate message, is there's no purpose of coming and just watching if you're not going to kick the ball. And so inevitably, you'll have students who will dwindle down and will no longer come and participate because they're not kicking the ball, and they'll realize themselves that, hey, this material seems hard. Well, it's not hard. It's just that you're not, again, practicing. But it's not a perfect system because I did notice that some of the replets were asking questions that you would have needed the information from today to be able to solve. And so if you found yourself challenged on some of the replets, and having to look online for ideas, or you never really have to look online, you just really have to go to the module and read ahead. And the modules are all online at the website that for our boot camp, which is at my website. So all you need to do is really go to my website. Bear with me. All you really need to do is go to my website and then click on the bootcamp. Is my internet working? So click on the bootcamp and then click on the module 4, and then just read ahead, which don't do right now because I want to be able to ask you questions from this. So don't pull this up in the moment, please, because that would kind of defeat the purpose of my asking you questions. But when you're ever doing replets, if you find that, hey, I'm not sure if we covered that, well, then just go read ahead, and maybe it's something we did not yet cover. So yeah, I did notice that some of the replets I had posted online, I noticed this morning actually, were asking questions where you really needed to have covered just a little bit more material, which we're going to jump into right now. And that'll happen every now and then, and which is good. That's not necessarily a problem. You may feel and find yourself challenged, which again is not a bad thing. So I'd like to pick up from where we were last time. We covered if and else statements. And here's just a very simple problem I want to give you. Write an if statement that increases pay by 3% if score is greater than 90. Otherwise, it increases pay by 1%. Really straightforward, pretty simple. Someone tell me how I would do that. So assume that we have a variable pay that that contains someone's pay, their salary. So we can call it pay or salary. So pay equals, let's just say that your pay was, let's pick a nice number, nice even number, $100,000 for the year. That's your annual pay or salary. And let's just say that you have some score that you got on the exam, and score is whatever score might be. Okay, score could be 95, score could be 75. Score is something. So after that, I want someone to give me the code. Someone tell me, write an if statement that increases pay by 3% if score is greater than 90. Otherwise, if the score is not greater than 90, strictly greater than 90, we should increase pay by only 1%. Someone give me that line of code. If what?
If pay is, hold up.
Yep, hold up. Someone else try. It's okay. I appreciate you trying. We're gonna make mistakes, and that's no problem with that.
If score is greater than 90, then that colon increase pay by 3%.
So how do I increase pay by 3%?
So pay times 0.03 in this case. I'm going by decimals in my head, sorry.
That's fine. That is 3%.
And then next line, remove tab, else, colon, increase by 1% because,
Well, let's
right?
fix this first. Let's fix this first.
All
Here,
right.
let's say pay was 100,000. This right here is going to be 3,000. So all you did is you calculated 3,000.
Right.
So what do we do now?
Right.
You're on the right track. Just fix this. What do we do on the left side?
On the left side, so that would be the increase, how
Yep.
much it goes up. So just some variable in this case.
No, we
would
want to
work.
use the same variable. We want to start with pay. Pay equals
Pay
what?
is equal to pay plus parentheses pay times 0.03.
Yep. Nice. Okay.
Otherwise, else, colon, space, make sure there's a tab. The same thing except replace 0.03 with 0.01.
Perfect. So pay equals pay times 0.01. That is absolutely correct. Anyone have another solution? Just from stuff that we've learned, that is perfectly valid, but is there any ways you can maybe make that a little bit better? Not better, different. No one else? Last chance.
Couldn't you put like the shift 8 near the equals?
Ah, good job. Good memory. So if score is greater than 90, you're saying 1, 2, 3, 4, you're saying pay times equals. And because what is the times equals? It says takes the previous version of pay and then add to that the new thing, pay times, and if you want to put it in parentheses to make it feel better, that's okay too, pay times 0.03. And we can even improve it.
Wouldn't
I'm
that be
sorry,
add
you're
equal?
right, absolutely. So it would be plus equals pay times 0.03. And then else, colon, pay plus equals pay times 0.01. And there's still even one more way we could have done this. And I saw Rebecca, you had your hand up?
Sorry, my computer's being slow. You could do pay equals pay times 1.03.
There you go. You could have said pay equals pay times 1.03, and in which case, using the augmented operators, kind of like what we did below, how else could you have stated that exact same line?
Pay times equals 1.03.
Perfect. Pay times equals 1.03. So what we can actually do is, and we'll talk about all of these. So here we can say if score is greater than 90, pay times equal 1.03, else pay times equal 1.01. So let's make sure we understand these real quick. And so here's the challenge, as I said, the balancing act, where I could have just zoomed right through that and 2, 3 of us get it, but I want to make sure we understand these things. So here, this one's perfectly fine. Nothing wrong with that. And I think it's something that everyone can understand. This is, we start the assignment by looking on the right side. And so if pay was 100,000, this here is 100,000, and we're adding to 100,000 times 0.03, which is going to become $3,000. So the resulting pay will be $103,000. I'm sorry, $103,000, which in fact is 3% greater. So that works perfectly fine. The next iteration was, well, the next iteration of thought was, hey, since we're doing this previous version of pay and adding to it this new amount, we can do plus equals. So take the 100,000 in pay and let's add to it 3,000, or take the 100,000 and let's add to it 1,000. That all works fine. And then the final iteration is, hey, well, what is really, if I'm taking the original pay and then I'm adding to it pay times 0.03, well, that's really taking the original pay and multiplying it times 1.03. That's the exact same thing mathematically, right? And anyone who doesn't assume that, I'm sorry, anyone who doesn't understand that, that's a math thing. I don't know what grades we start learning that in, but that's probably like 8th, 9th grade. So I think you'll all get that. So here, and if you allow me just very quickly, I think it's worth typing. So if we were to have pay plus pay times 0.03, this is factoring. Factor out your pay. What are you left with? You're left with 1 plus 0.03, and that is pay times, I guess I should put the times here for clarity. Okay, that is now pay times 1.03. So if you want to know where all that happens mathematically. So all of that said, I think this is, we've fully covered this slide. The result is we could have done it this way. And I notice I showed both within the if statement or the else. I showed the two different ways, one with augmented operators, one without it. Okay, another example. What is the printout of the code in A and B if number is 30 and 35 respectively? So look at A first, and this is a very important example. So let's focus on A, and let's say, what if A was, so what if number is 30? So if number right here is 30, someone tell me what's going to print right here.
Is even, followed by 30 is odd.
Here, that's correct. Here, now we know that 30 is not an odd number, okay, but I'm asking you what's going to actually get printed. Well, let's look at the code. We said assume number is 30. So in 30 mod 2, so when we divide 30 by 2, integer division, there in fact is no remainder. So we will go inside the if statement, and we're going to print 30 is even. Now this print statement right here that comes afterwards, notice it's not inside the if statement. It's not indented over. It's also not part of an else statement. It's just independent on its own, which means it will get executed regardless of the if statement above. So here it's going to print 30 is odd, which is obviously not a correct statement logically, but that is what will get printed. So now what is 35? If number is 35, what gets printed? For A. Quickly.
Number is odd.
Yeah, because 35 mod 2 will not be equal to 0 because 35 is an odd number, and you divide it by 2, it'll have a remainder of 1. So this if statement is false, therefore we will not execute this print statement. And then we just finish that if statement and we come down here and we print this number as odd regardless. Now let's look at B. What about if number is 30? What's going to actually get printed?
Number is even.
Absolutely, thank you. Number is even will get printed because 30 mod 2 does in fact equal 0. Number is even will get printed, and there's a typo here from the publisher because I actually copy pasted this particular image from the publisher, and there should have been a colon here. Assume there's a colon. So it would have printed number is even, and the number is odd won't get printed because logically that is inside an else. And so the way if-else's work, as covered last time, if this is a true statement, meaning if this Boolean expression right here is true, we don't execute the else part. We go inside the if, we execute this if, we execute that print statement, and we ignore the else, okay? But now, if this Boolean expression is false, so look at when number is 35. Number mod 2 equals 0, that's a false statement. 35 is, when you divide it by 2, it has a remainder of 1. So that is a false statement, which means we will not execute this print statement. Instead, we will execute the else, and we're going to print 35 is odd. Okay? So let me clear. And hopefully that all makes sense. So we want to cover today the idea of nested if and else statements. And then elif, we want to cover that as well. So I say here the short story is we can put if-else statements inside other if and else statements. Okay, so until now we've seen if statements, we've seen if-else statements. Now we can put those statements inside themselves. So I like how it's questioned here. What can you put inside an if statement? What can you put inside an else statement? And the answer is you can put inside them any legal Python statement. Okay, and a legal Python statement is another if or else statement. Pardon me. So here, the idea comes to us of nested if statements. Within if statements, you can have additional if and else statements. So the inner if statement is then considered to be nested inside the outer if statement. And even that inner if statement can have another if statement, and that one can have another if statement, and it can just go on and on and on. Okay, so there's no depth to the level of nesting. So here, notice I give, if we have these, 5 lines of code. So if I have values for I, j, and k, I can say, hey, what if I is greater than k? Then we go, if that's true, let me get my annotation pin. If this were a true statement, let's put some values. I was going to go code this up. Let's just put values here. So imagine that I equals, let me do this, text. Imagine that we know that I equals 5. Let's say that k equals 2. And let's say that j equals 3 on this example. So if that were a true statement, if I equals 5, k equals 2, and j equals 3, what's going to happen here? What's going to get printed? Someone tell me.
I and j are greater than k.
You're muted.
You're muted.
I is 5, k is 2. Is 5 greater than 2? What's the result of that, true or false? Quick.
True.
Yeah, that's a true statement. So this is a true statement. So which means we're going to go inside this if, because that's true. So if that were a false statement, we would not go inside the if. And for clarity, what is inside the if? Everything right there that's indented over. So this is inside the if, and even this is inside that outer if, but this line really belongs to this if because of the fact it's indented right there. But what's inside this if? All of these lines right there, those 2 lines. Can y'all hear me? I'm getting a message saying my internet connection is not the best from Zoom. I don't know why, but weird. So I want to make sure you can hear me. So if I is greater than k, which it was on this example, we're going to go inside this if statement. So this is true. And so now we go inside that if statement. So now we're looking at this part. Is j greater than k? Well, j is 3 and k is 2. Is 3 greater than 2? That's a true statement. And therefore, we go inside that if statement. Well, what's inside that if statement? This. And so now we're going to print I and j are greater than k. That is correct. Okay, so let's change the value. What if I want to say I is 5, j is, or how about k is 3, and how about j is 2? What's going to get printed here? Don't make assumptions. Think about it. What gets printed there?
Nothing.
Ah, nothing gets printed there. Can you explain that?
Well, in the first if statement, you have I is greater than K, I is 5, K is 3, 5 is greater than 3, therefore you're going to move inside. Next statement is if J is greater than K, J is 2, K is 3, 2 is not greater than 3, so we're not going to enter that if statement. But since we enter the first, we're not going to enter the else statement, so it's just going to terminate.
So some people might say, okay, I'm with you. It makes sense. I'm not going to enter that if statement right here. Fine. So now, since that if statement fails, we're going to go get matched up with this else. Why does that not make sense?
Because that else is matched up with the first if statement, not the inner one.
So you're saying that this else here is matched up with this if, and I'll say that that's correct. Now, how do you know it's matched up with the if? How do you know that this else is not matched with this if? I'm asking you.
Indentation, yeah.
Yeah. So how do you know that this else is not matched up with this if? Based on the indentation, which is actually, it's a beautiful thing. If you've studied another language, you'll appreciate that about Python. The fact that it forces you to have correct styling and correct indentation. So we can know if they're matched up by looking at that indentation right there. This else is lined up with this if. Okay. So in this example, nothing gets printed. Why? Because this if statement is true, which means we are going to go inside it to right here. And that guarantees, since this is true, it guarantees that we will absolutely not run this if and its matching print statement. Okay, because this is true, so we're going to go inside it. Well, when we go inside it, we look at this if statement. Is J greater than K? Is 2 greater than 3? No. So that is false, which means we will not execute this print statement. And you notice that this if statement right here, it has no matching else. There is no else right here that lines up with it. And so in fact, nothing gets printed. Give me a set of numbers, someone else, give me a set of numbers for I, J, and K that will result in the final else getting printed. I equals what?
I could equal 2.
I is 2. What does K equal?
5.
K equals 5. And frankly, we don't care what J equals. J can be anything. Thank you, Rebecca. Because if I is 2 and K is 5, basically what Rebecca did is she just gave us a set of numbers that will guarantee this to be false. Any I that is not greater than K. So we could have set I and K both equal to 5. So any I that is not greater than K will result in this being false, which means we will not enter the if statement. So we won't even look at this. That won't get looked at. This won't get looked at, and we will come execute the else. So there's some logic there. And it's not that it's hard, but it's new for us. The idea of now nested if statements. So I wanted to go through that a little bit slowly to make sure we understand. So when is nesting useful? Whenever we have multiple alternatives. So consider the following. This is the famous grade scale. And let me start by telling you, this is not how we would code this, not in Python, not in any other language. This is going to help us get to what we see at the top of our screen, the idea of if-elif. Okay, that's going to come up in just a couple of minutes. But it's a good teaching example to look at how this logically works. So anyone who's in school knows the famous grading scale. Let me come put that. What is the grading scale? We have anything from what is it, 90 to 100. I'll do it this way. An A is what? 90 to 100. What is a B? A B is 80 to 89. I'm guessing, right? I'm assuming most schools are the same. You might have B minuses, B pluses, and so on, but for the most part, sorry, B is 80 to 89. A C is 70 to 79. A D is 60 to 69, and an F is a clear indication that someone's not trying. Anything that is less than 60. So let's look at the logic here of how you can do that in code. We say if the score is greater or equal to 90, you have an A, end of story, and we're done. We've calculated the grade. And none of this gets executed. if the score was, let me come put over here. I'll type score equals 92. So if the score is a 92, this will be a true statement. And so we're going to enter that if statement, and grade will be assigned the letter A, and we will not execute any of that. Why? Because if this is true right here, if this statement becomes true, the matching else does not get executed, and anything inside that matching else does not get executed. So that will not get executed. End of story, grade is A. What if the score was an 87? Well, is the score greater or equal to 90? No. So this is a false statement. Okay, that's false. So we're going to come to the matching else. Well, look inside that matching else. And unfortunately, I'm looking at this example again. Horrible tabbing. I'm really disappointed with this publisher. I copied, these are my slides that I made. I'm proud of them. I made them from the book, but I used the images from the book. And I know I pointed this out to my class when I teach it, but the spacing here, it's a mistake. Mistakes will happen. But that else is intended to be matched up with this if, and it's just the spacing's wrong. In which case, if I ran this code in Python right now, it would actually not even run. It would give you an error due to the spacing. Okay, so heads up, I want you to be aware of that. This code would give you an error. It would not even run due to the fact that you have an else right here that's not matched up with an if. So we see that this if and else are matched, this if and else are matched, this if and else are matched, and just trust me, the intention is for these two to be matched. And so really, all of this needs to get spaced over 2 spaces in order to match up, right? That needs to have 2 spaces, but then everything else needs to be matched over. But let's continue the example. If score was 87, it's not greater or equal to 90, so that's false, which means we're not going to execute that, and we come to the matching else. Well, when we look at the matching else and we automatically go inside it, and we come here, and now we look at this if statement. Is score greater or equal to 80? It is. Score is 87, which means we're going to come, so this is true. We come inside this if statement, and we assign grade B. And we're done, which means we don't execute any of that. Because again, once an if statement is true, this if statement here became true, we do not execute its matching else. We don't execute it. We skip it. I'm pausing there for emphasis. I want to make that very clear. We skip that matching else statement. Okay, so let's look at another example. What if the score was 72? If the score is a 72, bear with me. I need to hit X here. Cool. So what happens now if the score is a 72? What happens is this is false. So we're going to come to the matching else, and we look inside that else, and we start with this if. Is score greater or equal to 80? Nope, that's false. So we look at the matching else. Well, this matching else, we look inside it, and when we look inside it, we have this if statement. And it says if score is greater than 70. It's a 72. That's true. So now we assign grade the value of C, and we therefore ignore and skip all of that. So there's some thought here of how this one works, because it's the nested if else, there's just additional logic required. Let's look at the final 2 examples. What if we had a 67? So here, 67 is not greater than 90, so that's false. We go to the matching else here. Is 67 greater or equal to 80? No, that's false. So we go to the matching else. In theory, it would be matching up with that if. It is score greater or equal to 70? No, that's false. So it's because that if was false, we look at its matching else, and its matching else has an if statement inside it. Is score greater or equal to 60? It is. So therefore, we execute that line, and grade becomes D. And then, so here grade would be D, and we would skip the remainder. And the final example was if score was less than 60. Okay, if score was, unfortunately a 40, student just, I don't know what to say. So here, that would be false. we enter the matching else, we look at the if inside there, that's false, so we look at its matching else, and the if inside that matching else, this becomes false. We look at its matching else, we come and we look at this if, is score greater than 60? Nope, that's false. So we look at this matching else, which does not have an if else inside it. It's just the final step of assign a grade of an F. So tell me something in the participant window, put a thumbs up if you understand that perfectly. I'm looking for thumbs if you understand that perfectly. Cool. That doesn't mean you can code it. That's fine, because you have to practice to be able to code it, but we understand that perfectly. Okay, so we've gone through that in detail. So this is just a flow chart to show you what's really going on that example, which I can now skip because we covered that in great detail. Cool. So that becomes very difficult to read and very difficult logically to even follow. So here, this is the one that I actually coded up myself. Notice that's everything is now matching, right? So the other one I had copy pasted from the publisher, but here, those match, those match, those match, and these match. And I want to take a moment of pause to point out that I heard the word tab earlier, and I even tab in Thani every now and then because I have my Thani set up to put 4 spaces. In Java, it's always in a language, there's a debate. Do you put a tab or do you put like this? Should it be a tab by hitting the tab key on your keyboard, or should you put spaces? And it's not really a debate to be had because you have to follow the style guidelines of that language. So if you wrote code and you only put tabs on your own personal computer, it might work. But if a person was hired somewhere as a Python programmer and you put tabs, and I know it might sound silly, but they'd warn you once, twice, thrice. But after that, if you just stubbornly kept putting tabs, they would stubbornly fire you because it might seem silly, but when you have, again, hundreds or thousands of people working all in the same code within the same language, they want it consistent. And the Python style guidelines, personally, I don't like it. If I was the creator, I would choose tab. But regardless, those who are in charge of creating the style rules for Python, they have created it with 4 spaces. So not 3, but actually 4 spaces. Was there someone who commented? No. So you need to put 4 spaces in here for Python. Now, if you were studying this bootcamp with me with the Java language, I would say don't ever put spaces and always put tabs. And we would never use spaces. So it depends on the language. And I will tell you the truth, full disclosure, it pains me when I put 4 spaces, but because I'm a Java programmer more than I'm a Python programmer, but that is the style for Python. So you need to fall in line and follow the style of that particular programming language. But I wanted to point that out. That is very important. So you want to get in the habit of using the correct styles of the given language. Let's see here. We have 4 minutes left. So that's hard to read, and it's logically hard to follow. So instead, what we're also introducing today is this idea of if. So we've introduced, what have we introduced thus far? Nested statements, right? These are all nested. So all of this stuff is nested inside this else. And then inside this else, all of this stuff is nested. And then inside this else, all of this stuff is nested. And that's just ugly and hard to read. But sometimes it's logically helpful to do that. Okay, it depends on the problem you're solving. But on this particular example, that's really ugly and hard to follow. And instead of that, there's something much better, the idea of using elif. In other languages, it would be called else if. And this is much easier to understand and explain. And in fact, there's probably little explanation needed. So I'll simply cover it. What if the score was a 97? If the score is a 97, just look. If score greater equal to 90, that becomes a true statement. Therefore, we execute this. We go inside that if statement. We execute that line of code. Grade is assigned the value of an A. And once we have on any of these things, once we have a single true statement, we ignore all of the rest. So all of that right there gets ignored. And when I say any of these things, so look here on this one block of code, we have, I'll say 5 things. We have an if, an elif, an elif, an elif, and an else. Those are 5 things. Once any one of those things becomes true, we skip all of the rest. Make sure that's very clear. So here, once this line becomes true, we evaluate, we execute that statement, and then all of this gets skipped. So now imagine that the score was 81. This statement is false, therefore we continue to the elif, which means else if. So we're saying, is the score greater than 90? Nope, false. Okay, so else if, is the score greater or equal to 80? Yes, that's true. So we execute this line, and again, we skip all of the rest. What if the score was a 59? Is the score greater than 90? No, that's false. So we continue. Else if, is the score greater 80? No, that's false. Else if, is the score greater or equal to 70? That's false. Else if, is the score greater or equal to 60? That's false. Finally, we say, well, if none of that's true, unfortunately, the grade's an F. So this is the idea of multi-way if, elif, elif, elif statements. You can have an unlimited number of elif statements here. Depends on the logic of the program you're solving. You can have 100 of them. You can have 1,000 of them. And you end with a final else statement. And again, depends on your logic. Maybe you don't want to do that. There's rare circumstances, but sometimes it's better to not even have the else. Again, it depends. But if you have the logic such that based off of all of these things being false, there is one final option, then that's when you use the else. So here we can have any number of elif statements, but the takeaway is once a single thing becomes true, we skip all of the remaining. So we're out of time for this session. I'm going to hit stop share, and I'm going to end the meeting and post another link within Slack.